I don't know that we ever lost hope. I mean, that was not an issue. I mean, this was a problem to solve, and you were gonna help participate in the resolution of that problem.
Early on, until we got around the moon, the flight directors really needed to keep the lunar module at a fairly high power mode to maintain the knowledge of where you were in space, to keep the IMUs up, to keep the computers up, and all that, because the CSM was down at this point. So they had copied all the data over when the lunar module was powered up, and they had to stay that way. Well, that was too much power. We'd never make it back all the way back around the moon with that amount of power. So from where I sat, it was, we need to get this thing powered down as soon as we can, but the guidance and navigation and getting back around and getting back onto a free return trajectory obviously took precedence. Once we got around the moon and on the way back, and they made the big descent engine burn to speed things up, and I think they made a separate one later, go into a power down. And once they were in the power down, it got powered down to about 300 watts. And at that point, consumable wise, make it. So if nothing else bad happened from the lunar module perspective, we could make it. So then it was a matter of monitoring, but we had to turn off a lot of equipment.
And the interesting thing was, here you had a stack of the spacecraft that are not supposed to be together, controlled by the lunar module, which is not supposed to control the stack, basically. And you're doing not only that long burn, but you're doing this mid-course correction that you do. And it was done essentially, I think the mid-course correction was essentially done manually. And was unlike anything that they had really practiced. And Love and those guys had to essentially learn to do that at the time they were doing it.